people hate that energy anyway. Is it going? Oh, sorry. I didn't know we started. Okay, so we're moving on to section 2.1, and we did a little bit of bell work, just reminding of equations of lines. Just like I told you guys already, lines come back, all right? It's actually the polynomial section. We're going to move on to x to the thirds, x to the fourths, x to the fifths, but the first polynomial is linear, x to the first. So yes, you can't walk out of my class without knowing how to find the equation of a line. All right, so that's why we kind of reviewed that again. We need our algebra skills brushed up. All right, like I said, a lot of people want to get mad about being in this class and with this ugly, bad teacher that we have right here. But the things that we're messing up right now are previous stuff. It really has nothing to do with the new CAT stuff. So we need our skills of multiplying corrected, and our skills for sure. I've said from before, of factoring, right? The basics of that. Because now what we're going to get into is polynomials. Now don't write this down. I think I put this in here just to show you that sometimes a math book is really, really, really math intensive as far as how it's written. But what this first thing says is, what does a polynomial look like? Yikes. This looks like a monster. And all this says is a sub n, that first thing that you look at is some, the light just keeps going on and off in our class. We have a ghost. Is some leading coefficient, and then x raised to some n power, whatever power that may be. Like I just said, we're going to move on. We're going to have x to the fourth, x to the sixth, x to the eighth. Then we're going to do the polynomial dance. What do the graphs look like, which we've already discussed, right? X to the fourth looks like this, right? Okay, so definitely some things we're going to look into here. And then everything after that x to the n minus 1, it just means x to the n is the highest degree. Then it goes down from there, all right? And that's all that we got going on here. So that's what it's saying about what is a polynomial. So now you can play the game at lunch, polynomial, not a polynomial. You can write a little equation down on your piece of paper and pass it to your friend and then say, hey, polynomial, not a polynomial. I love some smile and some look like they want to kill me in this class. That's okay. Big divide. All right. So go ahead and take a look at that. Write that down as an example answered. All right. So polynomial for number 1 for sure. It's got the classic 4x to the third minus 5x. It's called a cubic. All right. And then the degree, therefore, is 3. And the leading coefficient is that 4. We already talked about that. All right. Let's move along. How about letter B? Yes or no? No. You know what this is? This actually is a... Who said that? Who said rational? Right, nice. Because this is 6 over x to the fourth. That's a rational function, which has a vertical asymptote and a horizontal asymptote, and then that's actually later on in this chapter. So I lied. The chapter's all about polynomials. No, it ends with rational functions as well. So we do get a little couple of that. What about C? What's the matter? What? Ooh, here's what's tough about C. I hope you didn't think this happens. This is another illegal maneuver. How can I explain this? Wrong. This is not equal to that. Here's an example. What's 3 squared plus 4 squared? Does anyone know their Pythagorean triples? 3 squared plus 4 squared equals 5 squared. Does that mean 3 plus 4 equals 5? True or false? That's a false. I have students do that all the time. So what I'm saying is, if I square rooted both of these sides, you don't square root the 3 and square root the 4 squared, the 3 squared and the 4 squared. That doesn't happen. So this is not true if that's what you were thinking. This is definitely not a polynomial. This is some weird square root function that we don't really know what it looks like, and probably until we look at it on the calculator. Trying to hit that pen, it won't go. So no, that is not a polynomial, and that's okay if you said it might be. What about the last one? What about that last one? That's definitely a polynomial. So that's a yes, and the leading coefficient, the degree is 4, and it's a negative 2 for the leading coefficients. Looking into the future, that means the graph you would expect to look something like that, the old polynomial graph game. All right, and that's something we'll hit later. Got a question? So I'm going to pause that video. You okay? All right. All right. If you want to write this, fine. If not, it's not a big deal. There's not a name after quadratic. Actually, that's a lie. There's two more names after this. But we could have constant functions. Did I press play? Let's just make sure for the glorious video, especially for people taking a test. Linear function, of course, to the first power, quadratic to the second, and then I can write a couple more, like ax cubed, if I could get my pen. That's an A. Ax cubed, cubic, and then ax to the fourth is actually called quartic. And then actually, does anyone know what a fifth power is called? Quintic, correct. And so on and so on and so forth. I'm sure there's names for x to the sixth, x to the seventh. I don't even know what they are. So not popular, not ones probably to be held accountable. So we'll just leave that at that. Okay, now, working with these things, a lot of times they will give you points, and then you're going to have to come up with an equation that mirrors that stuff. That's a big mathematical concept. Your job is actually to read the question, all right, and pull out the pertinent information. And as you're reading and writing this down, the pertinent information is this is linear, okay? So what do lines have? It starts with an S, SL, SLO, slope, okay? And then, lines look like what we looked in the bell work, like I told you Brianna Samuelis is doing. I just helped her literally last night on a linear equation worksheet. So, but look at this notation. What? What's f of negative 1 equals 2? What does that make negative 1? That's x. Okay, so this is x, and then what does that make 2? Y. And that's exactly how it's going to be worded on your very next quiz. And you're going to have to handle it. All right, it's just function notation that says this is a coordinate. Input, say it's. Output, and then this is x, and this is y. And 2 points make a line. So here we go again. Write an equation of a linear. We just did this in the bell work. So I'm not going to ask you. I'm just going to go ahead and start doing my slope. M equals. If we don't know this at this point, yikes. Okay. Over 3 minus negative 1. Hopefully I don't make any mistakes there. So negative 2 minus 2. 3 minus negative 1. You get negative 4 over 4, which is negative 1. Then y minus, I'm doing point slope because I love it. And you just take a pick. I'm going to pick the first point. So it's y minus 2 equals negative 1. And then x minus negative 1, I'll go ahead and make that x plus 1. Now notice what it says. Write an equation for the linear function. Back in chapter A and P, we made you specifically write it in a form. I said put it in point slope form, put it in slope intercept form, or put it in standard form. If they don't say anything, circle it up. You're done. They don't give you any direction on what the form should be, then that's it. Hallelujah. Nothing else to do. By the way, hallelujah is just a general term of rejoice. It's not tied to any specific thing. All right? Okay, the next thing we're going to move on to is quadratics. There's where the big math is coming. All right? And I could show you something. I think I might. Two forms we're going to look at today. Actually, the main one we're going to look at is the second form. Turning what's called standard form, ax squared plus bx plus c, into what's called vertex form, which we could think of as last chapter's transformed form. Move right, left, up, down. Yeah. All right. But looking at this yellow graph, does anyone know what the vertex is? Yeah, we should. It's a little formula. The vertex of this yellow equation. All right? And it's actually in a coordinate form. You're going to probably need more room on that other side there. Anyone? 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 Once I put negative and then b, people remembered. Whatever the number is for b, and whatever the number is for A. The vertex's x-coordinate for that parabola in standard form is negative b over 2a. It's a formula. It's kind of related to the quadratic formula. It actually is. And then what does this mean? It just means you plug in whatever that number is for this into x and then find out the output, which is the y value of the coordinate. All right, but we're going to kind of avoid that. We're going to do what's called completing the square today. This is a very big math skill that will happen at least at the end of this semester, or right around at the end, like towards November. Probably we're really going to be hitting that hard. So what I'm going to do is I'm going to take this equation that's in standard form. You don't have to write the whole thing out. And do what's called completing the square in order to get it in the form that's listed up here. It is complicated. This is going to be the most complicated thing you're going to do today. That's why I'm going to do probably 3 examples of it, maybe more. All right? And then end with a doozy. So here's the first one. First of all, what you want to do is write this in descending order. And unfortunately, right away, we have a tough one. So I probably should have started a little bit easier. But hopefully you can handle it. Plus 6x minus 5. Now remember what our final result is. We want it to look like this, which I'm going to put in the corner here. F of x equals a x minus h x, and then squared, plus k. And then we can find out what the vertex is. The vertex is h comma k, which was listed up there above for that situation. Here's step number 1. All right. Step number 1 is to actually take out a negative 3. And actually, my bad, group this and only take a negative 3 out of those first 2 terms. Because this minus 5 over here is not k, but it's going to be part of what finding k. Like another number is going to be added to it. So we don't want it part of this grouping and taking this negative 3 out kind of thing. And then, hold on. Put a blank right now. Then close it, and then put this minus 5 here. And then I forgot. I'm going to erase this and put a blank over here, because whatever you do to one side, say it. You do to the other. And in that blank, I'm going to fill in a magic number that is actually going to make a perfect factoring situation that gets me a set of parentheses that look like that. So again, looking at what the end should look like, this is why I'm doing what I'm doing right here. Okay, quick question. Question in class, what I'm trying to do with that blank that I filled in is totally tied into what we did for the bell work. I need a perfect factorable situation so it looks like this when you're done. So what I have to accomplish is this number right there. That's what I'm going to put in that blank. Not 4, but the number that makes the trinomial a perfect square binomial. All right? So how do you do that? All right, here we go. Remember for the test, when I say inverse, I know I go all over the place, but there's a reason. When I say inverse, you say switch x and y. Oh my gosh, how many people didn't even do step 1? I had 2 inverse questions on the written. I don't know what we can do about this, you know? We got to do those basic things. Well, here we go. When I say complete the square, you say you don't know. I'll tell you. When I say complete the square, you say take half of this middle term. What's half of negative 2? Negative 1. Then square it. Now don't say negative 1 squared on your calculator. What's negative 1 squared? 1. And that's what you put in the blank. And now what you've done is created what's called a perfect square trinomial. Whatever you do to one side, say it. Whatever you do to one side, say it. What goes in the blank on the other side, the left side? Don't say 1! It's not 1. Look at the right side and actually analyze what did you add to the right side. Not 1, but negative 3. This keeps the balance of your equation. Keeps it balanced, and you didn't. It keeps it, equilibrium. It keeps its equilibrium. I always think of an equal sign as like a state of equilibrium. Whatever I do on the right side, I got to do the same on the left. Sammy Samuelis, in 7th grade, we were solving equations, literal equations, actually, that you did. And I told her about that fulcrum and blah, 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 blah. All right, so that's the trick. A lot of people are going to put 1 there. All right, and then that's going to cause a problem. And then guess what? The next step is factor. And maybe go ahead and add that 3 to both sides. Like I said, this 5, this minus 5, is part of what K ends up becoming. And then basically you're going to be done, because what is this factor as? What multiplies to 1 and then adds to negative 2. What numbers? Minus 1, minus 1. Okay? Now you could say that the vertex of this is what? 1 comma negative 2. And then we could graph it and sketch it, and I'll probably look at that with some others. All right, probably a lot of questions, but like I say, I'm going to do a few more and let it sink in. Okay, a tougher one again. What do I have to do first? What do I have to do first for 3x squared plus 12x plus 11? Group, and then what do I pull out of that first that set of parentheses? What number? A 3. Okay, so I have, now watch this, f of x. Now I know I'm going to start adding something, and I can make f of x y if it helped you, but that's all f of x is. I'm going to pull out that 3. This 12 becomes a 4. Don't pull out an x with it, because basically what you're trying to do is get this to be a perfect square trinomial, so that it factors to be a binomial times itself. Then I told you about this 11. This will just be part of, the y-coordinate of the vertex. All right? All right, when I say complete the square, you say take half of the middle term. What's half of 4? And then square it. What's 2 squared? 4. Okay, what do I put on the other side, though? What did I actually add to the right side? Not 4, I added what? 12. Okay, now we got more people on board. Now, what we got to understand is, and why I had to pull that 3 out, this is a perfect MA factoring situation. What multiplies to be 4, and then the same 2 numbers add to be 4. What are the numbers? 2 and 2. So the very next step, fine, I'll slow it down. I'll leave that 12 over there. And then we'll make that the last thing that we do, subtract 12. 3, this factors to be x plus 2 times x plus 2. The factoring that we did in the bell work. That's why the bell work, the book was awesome about what skills are needed for this section. Then I could subtract 12, write this in a format that's nice. F of x equals 3x plus 2 squared minus 1. All right, and now the vertex for this is actually negative 2, negative 1. All right, opposite same. Or think about your transformations. Plus 2 means 2 left, minus 1 means 1 down. And that's where the vertex is. And if I were to sketch this real quick, I would go negative 2, negative 1. And then this 3, what does that 3 do? Is it stretch it vertically or shrink it vertically? Stretch means push away, exactly. So actually what happens on the next point is down 3 and then over 1, and these would be the next 2 points. All right, and that's a quick sketch of that parabola right there. It's not negative. Oh my goodness, there we go, worst teacher ever. Oh, made a mistake. I'm human. Okay, you're right. Thanks for catching that. 1, 2, 3, 1. My bad, dogs. Riff. Oh, so ashamed of myself. Now it's going to get ugly. You want to get nuts? Let's get nuts. I think I had too many examples at another one that was on the easier side. This is definitely one of the hardest. Okay, I group. What do I have to pull out? Oh no. Okay, what do you see happening here? I now have a anyone? Fraction. I hate fractions, and he's a fraction jerk. He's just a jerk in general. X squared. All right. You don't do decimals. No decimals. No decimals. So when I take out a negative 2, I hope you know that this is negative 7 halves, right? Everyone okay? Okay, so 7 turns into a negative when I factor out a negative, and it becomes negative 7 halves. You have a couple of these in the homework that I want you to Make sure you know what's going on here. And then we have a -3 on the out. Remember, the -3 doesn't play this game. It's part of finding the k part. All right. What did I say? When I say complete the square, you say take. Now this is when you write it. You write it down. You take half of the middle term. What is half of the middle term? Correct. And then what do I do with -7/4? Square it. Now don't tell me you can't square -7/4. What's -7 squared? 49. I know people are starting to get an aneurysm right now, right? And then what's 4 squared? Because then you're going to say to me, you expect me to factor that? I have never done that in my life, and you're probably right. But before I go ahead and factor that, what goes on the other side? Oh no. It is this times this, which we established on our previous two examples. What is -2 times 49/16? It is -49 over 8. That's someone that can deal with a fraction. And it is a simple thing, but we make it difficult by not knowing our fraction rules. -2 times this, it actually cross-cancels with the 16. That's how someone got -8 on the bottom so quick. And that should be for everybody in this class, but we'll just move on. Do you know what the answer for factoring this is, though? It's actually staring you in the face. It actually is. Equals -2. And then I'm going to go ahead and write it like this, and then we'll write the final answer. Well, we know it's going to be x and x. That's the whole point of this. And we know that these are supposed to be the same numbers. What number multiplied by itself equals 49/16? And then when added together equals -7/2? Does anyone know what the answer that is? The actual numbers on the page. It is -7/4. This number is always the number that ends up being the factoring number. So you actually don't have to do anything except what I told you to do when you have complicated and nasty fractions. You write it out. You write out the half of the middle term and then square it. You write that work out, and then this always ends up, and now the robots will be hopefully, just memorizing that, but I hope you understand it. -7/4 times -7/4 is 49/16. And actually, -7/4 and -7/4 added together is -14/4, which reduces to be -7/2. So simple, basic MA factoring can make you understand this. All right? And now we got our last step, which is still a fractional problem. F of x equals. Well, I know I have -2 and then x minus 7/4 squared. And then I have to take -3 and add 49/8 to it because I got to add that 49/8 to the right side. So what am I going to make -3? I'm going to make that minus 24/8, right? Isn't that right? So my final answer is -2 x minus 7/4 squared. And then 49, 39, 29. Is that 25? And it's ugly, but that's what it is. The vertex of this would be then 7/4, comma, 25/8. And then it would go down and be vertically stretched by a factor of 2. Alrighty, there's your glorious